Welcome to English Podcast and Tech. I am Charles. Right now, as you listen to this episode, something extraordinary is happening. Millions of computers around the world are talking to each other, sending data, receiving data, every second, without stopping. But how do they understand each other? Computers are made by different companies. They run different software. They are in different countries, speaking different languages. The answer is that they all speak the same language, a language invented by two men in the 1970s. This is episode 11 of The People Who Built the Digital World. Today we meet Vint Cerf and Bob Kahn, the two engineers who created TCPIP, the communication protocol that makes the Internet possible. Without their work, there would be no Internet as we know it today. Let's begin. Let's learn today's key words. The first word is protocol. A protocol is a set of rules that defines how two or more parties communicate, what format to use, how to start and end a conversation, and how to handle errors. TCP/IP is a communication protocol. It defines exactly how computers send and receive data across a network. Every device connected to the Internet follows this protocol. Repeat after me. Protocol. The second word is packet. A packet is a small piece of data, a chunk of information sent across a network. When you send a message or download a file, the data is broken into many small packets. Each packet travels independently through the network and is reassembled at the destination. Repeat after me. Packet. The third word is network. A network is a group of computers or devices connected together so they can share information. The Internet is the largest network in the world, connecting billions of devices across every country on the planet. Repeat after me. Network. The fourth word is router. A router is a device that receives data packets and sends them toward their destination, choosing the best path through the network. Every time you connect to the Internet at home, your data passes through a router. Routers are the traffic controllers of the Internet. Repeat after me. Router. The fifth word is address. In computing, an address is a unique identifier for a device on a network, like a postal address, but for computers. Every device connected to the Internet has an IP address, a number that identifies it uniquely. When you send data, the protocol uses this address to make sure it arrives at the right place. Repeat after me. Address. The sixth word is reliable. Reliable means consistently working correctly. You can depend on it. Before TCP/IP, networks were not reliable. Data could lost, arrive out of order, or be corrupted. TCP/IP solved this. It guarantees that data arrives correctly and completely. Repeat after me. Reliable. The seventh word is open. In technology, open means available to everyone, not controlled by a single company or government. Cerf and Kahn made TCP/IP an open protocol. Any computer from any manufacturer in any country could use it for free. This decision is one reason the Internet grew so fast. Repeat after me. Open. The eighth word is scale. To scale means to grow in size while maintaining performance. To work just as well whether you have 10 users or 10 billion users. TCP/IP was designed to scale. In 1973, it connected a few dozen computers. Today, it connects more than 5 billion people. The same protocol, the same rules. Repeat after me. Scale. 8 words. Protocol, packet, network, router, address, reliable, open, scale. Now let's hear their story. To understand this story, We need to go back to the late 1960s to a project funded by the United States Department of Defense. The project is called ARPANET, Advanced Research Projects Agency Network. ARPANET is the first wide-area computer network in history. It connects 4 universities in the United States: UCLA, Stanford, UC Santa Barbara, and the University of Utah. On October 29, 1969, the first message is sent over ARPANET. A student at UCLA tries to type the word login and send it to a computer at Stanford. The system crashes after just 2 letters, L and O. The first message ever sent over a computer network is low. Not quite what they planned, but it works well enough to prove the concept. ARPANET grows slowly over the following years. More universities and research centers connect to it. But there is a fundamental problem. Every network uses a different language, a different protocol. Computers on ARPANET cannot communicate with computers on other networks. It is like having many cities, but the roads between them use different rules. Cars from one city cannot travel on the roads of another. Someone needs to create a universal language, a single protocol that all networks can use. That someone turns out to be 2 people. Robert Elliott Kahn, known as Bob Kahn, is born in 1938 in Brooklyn, New York. He studies electrical engineering at Princeton and later earns a PhD from MIT. Vint Grace Cerf, known as Vint Cerf, is born in 1943 in New Haven, Connecticut. He studies mathematics at Stanford University and later earns a PhD in computer science, also from UCLA. Cerf has been almost completely deaf since childhood. He wears hearing aids. He later says this experience made him think more carefully about communication, about how information travels from one person to another. Kahn joins ARPA, the Defense Advanced Research Projects Agency, in 1972. He is responsible for the technical design of ARPANET. In 1973, Kahn invites Cerf to collaborate on a specific problem: how to connect different networks so that their computers can communicate with each other. The 2 men begin working together. They meet in hotel lobbies, university offices, and conference rooms. They fill pages with diagrams and equations. Their key insight is simple but powerful. Instead of trying to force all networks to use the same technology, which is impossible, they will create a universal set of rules for how data travels between networks. The rules work like this. Data is broken into small pieces called packets. Each packet contains the data itself, the address of the sender, and the address of the destination. Packets travel independently through the network, each one finding its own path through routers. At the destination, the packets are reassembled in the correct order. If any packet is lost or corrupted, it is automatically sent again. This system has 2 parts. TCP, Transmission Control Protocol, handles breaking data into packets, sending them, and reassembling them correctly. IP, Internet Protocol, handles the addressing and routing, making sure each packet knows where it is going and how to get there. Together, TCP/IP becomes the universal language of the Internet. In 1974, Cerf and Kahn publish a paper describing their design. The title is A Protocol for Packet Network Intercommunication. This paper is one of the most important documents in the history of technology. Crucially, Cerf and Kahn decide to make TCP/IP completely open. No patents, no licensing fees. Any computer from any company in any country can implement it for free. This decision changes everything. Because TCP/IP is open, it spreads rapidly. Universities adopt it. Companies adopt it. Governments adopt it. On January 1st, 1983, a date known as Flag Day, ARPANET switches entirely to TCPIP. This moment is considered the birth of the modern Internet. From that point, the Internet grows at a speed nobody predicted. In 1983, there are a few hundred computers connected. By 1990, more than 300,000. By 2000, more than 300 million. By 2024, more than 5 billion people use the Internet. All of them, every single one, using the protocol that Vint, Cerf, and Kahn designed in a hotel lobby in 1973. In 2004, Cerf and Kahn received the ACM Turing Award, the most important prize in computer science, for their invention of TCP/IP. Vint Cerf later joins Google, where he serves as Chief Internet Evangelist, a title that perfectly describes his mission to bring the Internet to every person on the planet. Kahn continues working on Internet infrastructure and policy through his organization CNRI, the Corporation for National Research Initiatives. Today, when you send a message, stream a video, or open a website, your data travels as packets, following the rules that Cerf and Kahn wrote 50 years ago. The Internet has no single owner. No single country controls it. No single company runs it. It belongs to everyone, because Cerf and Kahn made it open. Let's review the 8 key words from today's episode. Protocol, a set of rules for communication. TCP/IP is the protocol that defines how every device on the Internet communicates. Packet, a small piece of data sent across a network. When you send any data over the Internet, it is broken into packets that travel independently. Network, a group of connected devices. The Internet is the largest network in the world, connecting billions of devices across every country. Router, a device that directs data packets toward their destination. Routers are the traffic controllers of the Internet. Address, a unique identifier for a device on a network. Every device connected to the Internet has an IP address so that data knows where to go. Reliable, consistently working correctly. TCP guarantees that data arrives correctly and completely, making the Internet reliable. Open, available to everyone without restrictions. Cerf and Kahn made TCP/IP open, free for any computer in any country to use. This is why the Internet grew so fast. Scale, to grow in size while maintaining performance. TCP/IP was designed to scale from a few dozen computers in 1973 to 5 billion people today. That is the story of Vint Cerf and Kahn, the fathers of the Internet. 2 engineers who solved an impossible problem with a simple idea. 2 men who gave the Internet to the world for free. Today's phrase to remember is, the Internet belongs to everyone. That is not just a nice idea. It is a technical reality built into the design of TCP/IP from the very beginning. Repeat after me. The Internet belongs to everyone. One more time. The Internet belongs to everyone. In the next episode, we meet Ted Nelson, the man who invented the concept of hypertext and dreamed of a universal library of human knowledge 30 years before the web existed. Your question for today in English: do you think the Internet should always remain open and free for everyone? Why? Write your answer in the comments. There is no wrong answer, just great English practice. See you in episode 12. This is Charles, and this is English Podcast and Tech.